Hi there, awesome people. Last time we explored ways to improve our bottom sheet. Right now, the content inside gets cut off and doesn't look quite right. In this video, we'll fix that and make it fully dynamic. To really highlight the issue, check out what happens when we switch to a smaller screen, like the iPhone SE. It even gets worse. The content gets squeezed and truncated, making the UI unusable. So let's try to fix that. My proposed solution will be a combination of preference keys, custom modifiers, and view extensions. But first, what I want you to remember about preference keys is that they basically allow views to pass data up the view hierarchy. It helps when you need a child view, in our example our bottom sheet, to communicate layout info like size or position or height back to a parent view. So let's create that preference key. Under the utilities folder, we need a new folder called UI helpers. Here, we will create a new folder called custom modifiers and another one called custom preference keys. Under the custom preference keys, we will create a new file from template, Swift file, next, and we will name this adaptable height preference key. We will create a struct for this. So struct adaptable height preference key. We're going to implement this protocol, preference key. It cannot find it, so let's import SwiftUI for this. Now, in order to conform to this protocol, we need to add the stubs for conformance. So write static var default value of type CG float, be optional. And the function that we need is static function reduce value in out CG float, next value that will return a CG float optional. First, we need to make sure that we have a value here because an optional could be nothing or could be something. So let's use a guard for that. Else return. And the value should be next value. So a few notes here, we have this adaptable height preference key that conforms to this preference key protocol. And basically what I've told you is that the preference key lets child views pass information back to a parent view. It provides an initial value if nothing else is set. And we have this important function reduce. It's called whenever a new value is reported. It updates the current value with the next one, allowing the app to track changes in the view height. But this is more or less a boilerplate code, so what I want you to remember is just that the preference keys help SwiftUI views dynamically adapt their size by passing height information from child views to the parent. Next, we want to use this preference key inside the view modifier. A view modifier in SwiftUI are methods that you use to change the appearance or behavior of a view. They take an existing view and return a new version of that view with the desired changes applied to it. So under custom modifiers, let's create a new file from template, Swift file. Let's call this adaptable height modifier. Hit create. Here we need to create a custom view modifier. Let's name it struct adaptable height modifier and conform to view modifier. This one needs a binding for the height, type CG float. You can name this whatever, so it might be a good idea to just name it current height. Let's import SwiftUI. It does not conform to protocol, so I think it needs a body. So let's define a body. The content. It needs the content, should be fine. Yes. Now this content needs to know the height of our content that is inside the bottom sheet. So for that, we need to use a geometry reader. So let's create a separate view, private var size view, some view. Let's use that geometry reader, geometry in. Let's use a color.clear.preference. And here we will use our custom preference key, adaptable height preference key dot self, and for the value, the dynamic height that we want to pass to that preference key is going to be geometry.size.height. I think this is key and this is value. Now let's use this size view inside the background of our content. One more thing, we need to listen to the height that is changing dynamically. So on that we have a listener called onPreferenceChange for adaptable height preference key dot self. We have the height that is received in. We need to make sure that we have valid height and just pass that height to our current height. So again, some notes here. We use a geometry reader, but basically it is a hidden geometry reader. We don't want to mess up the UI in our views. So we will use this geometry reader on a background that is clear, not visible. We will only need this to get the height of our content and pass it to the parent view. Our content, besides applying that size view as a background, also listens for changes using onPreference change. When the height updates, it assigns the value to the current height. And with these few lines of codes, we can make our view responsive by updating its size based on its content in real time. Now, to easily use this custom modifier across our entire app, it would be easier to create an extension on view. So under this folder, create a new file from template, Swift file, name it view, make it an extension on view. Let's create a function called read and bind height to height. It's going to be a binding of type CGFloat, and it's going to return a view. Self.modifier, adaptable height modifier with the binding height being the height. Of course, import SwiftUI. And we're done. We can use this read and bind height on any view. So if you go back to our home view and search for our sheet content view, have this Z stack, and we have these presentation detents here. What we really need is to know the height of this journal entry view. So in order to do that, we can just use our custom modifier, read and bind to height. Of course, we need a private variable declared in this home view to bind the height from this view to our variable. So for that, we can create a state variable at the top, state private var detent height of type CGFloat, and by default is going to be 0. So we're going to use that detent right here. We need to use $ detent height. And now instead of using this hard-coded medium value, we can use our dynamic height value. So .height detent height. And now, for example, on this iPhone SE, if we trigger the bottom sheet, we can see that our bottom sheet expanded really nicely. The same if we go on the iPhone 60 Pro and trigger the bottom sheet, we can see that the view grew, but it grew a lot, and we don't want it to grow that much. We just want to feed the content. So let's check the problem. So our problem can be solved with a simple modifier called fixed size. We need to fix the size on vertical position. So it's hit true here, and on horizontal we need false. So if you trigger the bottom sheet, we can see that it grows, but exactly as much as the content inside it. And the same thing for iPhone SE. Go back and trigger the bottom sheet. You can see that it's just enough to feed the content, not larger and not smaller. So that's really awesome, friends. But now let's go back to our add journal entry view and let's see how it behaves in our preview here. It kind of works because we defined a hard-coded value for the height. But if we go back to the medium value, we can see that it's truncated again. So the changes that we apply in the home view are not applying in this preview. So in order to make testing easier, we can integrate the new previewable state variables that are declared in the preview macro. So let's start typing at preview viewable at state var detent height type CGFloat, default value is 0. And now here we can use dot height detent height. Of course, we see nothing because the default value is 0. You need to apply that read and bind height modifier. On this view, we can just type read and bind height to detent height. And of course, we need that fixed size modifier also here. So fixed size, horizontal false, vertical true, and everything should be just fine. So we successfully tackled the truncated content issue, and I'm thrilled we worked through the solution together. We identified the problem, outlined a plan, and implemented a clean, effective fix. In the upcoming videos, we'll dive into integrating view models and explore different storage options. The focus will be on designing a flexible architecture that allows for quick and seamless transitions between data sources using solid design patterns. As always, thank you for watching and being part of this journey. Happy scribbling!